Welcome back, Algebra 1. You thought you were done for the day, but you are not. Alright, so we're going to finish up with adding polynomials here with the application practice. So we already did number 1 together. I want to keep going through 2 through 8. So that's all we're working on today is just this page. So you might want to go ahead and get an extra sheet of paper out because there's not a lot of room here, and I want to make sure you have enough room to write out the whole process. All right, so remember perimeter. You add up all the sides. Perimeter's adding. You're adding up all the sides. All right, so that's why it's application practice for adding polynomials, because we're adding up all the sides. And application just means applying what we learned to like a real-world situation. All right, so here you see we have 5 different sides. We're going to add up all of these sides. So I'm going to start off just by writing all of them. N plus 7 plus n plus 7 plus n plus 3 plus n plus 7 plus n plus 3. So you could add the parentheses if you wanted to. Like here's my first n plus 7. Here's my second n plus 7. There's my n plus 3. There's my third n plus 7. And there's my n plus 3. So you can write all that out together. There's also another way you could write it. Now, I want to show you as many different ways as possible for you to be able to pick up what you want and run with it. So if you'll notice, I have 3 n plus 7s. So I'm going to go ahead and write this down here. 3 times n plus 7. We're going to see if we get the same answer doing both ways. And then it looks like I have 2 n plus 3, so I'm going to do plus 2 times n plus 3. So these are the exact same thing. With this, I just wrote out n plus 7 3 times. Here, I did 3 times n plus 7. Up here, I wrote out n plus 3 twice. Down here, I did 2 times n plus 3. It should work out the same way, but we're going to try it out. We'll do this one in a second. Let's start off with this one. All right, so since I have the parentheses, technically I need to distribute what's on the outside, right? I don't see any numbers on the outside of these parentheses, so it looks like I'm distributing a 1. If I distribute a 1, and sorry, that 2 is not on the outside, that's just the problem number we're on. If I distribute a 1 to all of these terms, it's not going to change anything at all. 1 times anything is itself. So 1 times n is n. 1 times 7 is 7. So basically, when you distribute the 1, you get rid of the parentheses and nothing changes. So n plus 7, n plus 7, n plus 3, n plus 7, and n plus 3. I wrote everything out like this, and then I just wrote them all without the parentheses. All right, so now we're ready to identify like terms. It looks like we have a lot of n's, and they're all raised to the same power. What power are they raised to? What's the exponent? All right, I hope you said 1. So what I'm going to do is box them so I know, and then I'm going to write them next to each other. So it looks like I have n, and as soon as I write them, I'm going to cross them out so I know I dealt with them. Plus n, which was right there, plus n, plus n, plus n. So I should have 1, 2, 3, 4, 5 n's. 1, 2, 3, 4, 5. Yep. All right, now the rest of these, I'm going to circle them because they're constants. They're just numbers by itself, so they're also like terms. So plus 7, got that one. Plus 7. Plus 3. Plus 7. Plus 3. All right, now I'm ready to combine them. All I'm doing is adding the coefficients. So remember, when you don't see a coefficient in front of a number, you know that it's understood to be 1. So 1 plus 1 plus 1 plus 1 plus 1. That's going to give me 5n. There's 5 of these n's altogether. All right, I combined them all, so I crossed them out so I know I don't need to deal with them anymore. Now let's add up the constants. Let me grab my calculator on my phone. All right, 7 plus 7 plus 3 plus 7 plus 3. So it's going to be plus 27. And that's as simple as it gets, because these two are not like terms, so I can't combine them. So this is my perimeter. Perimeter equals 5n plus 27. All right, let's go ahead and try it the other way that we wrote. So remember here, I knew that we had 3n plus 7, so I just wrote it as 3 times n plus 7. And I knew I had 2n plus 3, so I wrote it out as 2 times n plus 3. All right, we see the first thing we need to do is distribute, and we're distributing whatever's on the outside of the parentheses. So 3 times n is 3n, and 3 times 7 is 21. You'll notice I put the plus sign in front of the 21 because there's a plus sign in front of the 7. Oh, that looks like an exclamation mark. Well, that's just something wrong with my paper, so I'm going to make it into a big 1. That's kind of confusing, but oh well. All right. Now I add another plus sign, right, because I have a plus sign in front of the 2. So plus 2n, because 2 times n is 2n, and then plus 6. So I think one of the biggest mistakes we make is we forget to put plus signs, and we need to bring down those plus signs if they're positive terms. All right, so from here we can identify like terms. So go ahead and tell me what the like terms are for the n terms. All right, I hope you said 3n and 2n. So I'm going to write those to be next to each other. And then I have 2 constants, plus 21 and plus 6. So now that I've got them next to each other, that's easy for me to combine. The 3n plus the 2n will give me 5n, and the 21 plus 6 gives me 27. So you'll see I get the same exact answer as above. 5n plus 27. So it's whatever way you prefer to write it down. If you just want to write down all the terms one by one, that's fine. If you want to count to see if we have the same number of n plus 7s and n plus 3s, that's fine as well. All right, let's go ahead and try number 3. All right. So number 3 looks like a parallelogram, right? So parallelograms, we can assume that the opposite sides are the same. So what I'm going to do is fill that in, 4w minus 3z, and the same over here, 4w minus 3z. All right, so I have 2 ways of writing this. I can write out this term 4 times, or since it's the same exact expression, I can do 4 times 4w3z. Let's do it both ways just so you can see how they both work again and see what you're most comfortable with. Remember, we're adding because that's how perimeter works. We add all the terms on the outside. All right, so here's my first expression. I just did each side added to each other. 4w minus 3z plus 4w minus 3z plus 4w minus 3z, and so on. All right. Now I know I need to distribute to get rid of the parentheses, and it looks like there's a 1 outside every single parentheses, which means it's not going to change anything at all. All right. Now we're ready to identify like terms. All of these have the same variable raised to the same power. That's what a like term is. W is the variable, and the exponent is 1. So since they all have the same variable with the same exponent, I can combine them. So I'm going to move them to be next to each other so that they're easier to combine. All right, I got all those next to each other. Now it looks like the minus 3z's are also all like terms because they have the same variable z raised to the same exponent of 1. So I'm going to go ahead and write them out. You'll notice I kept the subtraction sign in front of all of them because that'll make a difference. Alright, now that I have them all together, I'm going to go ahead and add the coefficients. So 4 plus 4 plus 4 plus 4. So that gives me 16w. And I combine all those w's. Now let's do the same thing with the 3's. Alright, so negative 3, minus 3, minus 3, minus 3. So that gives me minus 12z. Can I combine 16w and negative 12z? I hope you said no, because they are not like terms. This is a w and this is a z, so they have different coefficients. So this is my simplified answer, my perimeter, 16w minus 12z. All right, let's go ahead and try it the other way. The other way was that I knew that I had this same expression 4 times, so I can write it as 4 times 4w minus 3z. I'm just going to take one side and multiply it by 4. Alright, if I do that, I'm just going to distribute the 4. 4 times 4 is 16w, and 4 times negative 3 gives me minus 12z. So we end up with the same answer either way. But we can only multiply like this if we have the same expression on all sides. That's why I could multiply. All right, I want you to pause the video and try number 4 on your own, and then we're going to come and do it together. All right, let's go ahead and try this out. All right, so all I'm going to do is add up the 3 sides. So I'll start off with 20 minus b plus 20 minus b plus 3b. So I've got all my 3 sides. I'm adding them up. Now to get rid of the parentheses, I know that I'm going to distribute whatever's on the outside, which is a 1. And I know that multiplying things by 1 doesn't change anything, right? So I'm just going to drop my parentheses. So 20 minus b plus 20 minus b plus 3b. All right, I want you to take a second and identify all of the like terms. All right, I identified all of these with the variable b raised to the same exponent of 1. I know it's a 1 because I can't see it. All right. And notice I kept the subtraction sign with it. So negative b minus b plus 3b. Alright. Now my only other like terms are my 2 constants. So plus 20 plus 20. Remember, this is a positive 20, that's why I put plus. This is a positive 20, that's why I put plus. Alright, now since we grouped them, we can now go ahead and combine them. So I'm going to look at this group first, and I'm going to combine all these coefficients. All right, so that's a negative 1. If it helps to draw the 1 in front of it, go ahead and draw it. All right, so I have a negative 1 minus 1 plus 3. That gives me a positive 1b. Now remember, I don't need to write a 1 as a coefficient. It's understood. So you can go ahead and erase that 1 and just leave it as b. So when I combine all these together, I just get b. All right. Let's go ahead and add these 2 constants. 20 plus 20 is 40. And that's as far as I can go. These are not like terms, because this is a variable and this is a constant, so this is as simplified as I can get. All right, if I wanted to try it the other way, let's identify how many sides are the same. So I look and I see I have 2 sides that are 20 minus b. So I'm going to do 2 times 20 minus b. And then I have 1 side that's 3b. So I'm just going to do plus 3b. Because I only have 1 of those sides. All right, so looking at this, it looks like I need to distribute the 2. 2 times 20 is 40, and 2 times negative b is negative 2b. And then just bring down this last term that's outside of the parentheses, right? It doesn't get the 2 distributed to it because it's on the outside. From here, we can identify the like terms to be negative 2b and a positive 3b. So we know that, hey, sorry, another teacher came in to talk about the NFL football game. We can't believe the Colts lost. However, I can believe the Falcons lost. All right, so now that we've combined these, we have negative 2 plus 3. Sorry, you guys, I'm surprisingly popular this morning. That's not how it usually goes. All right, negative 2 plus 3 gives me 1. So these are going to combine to 1b, and I know I don't need to write the 1 because it's understood, and I'm just going to bring this 40 down. I put a plus sign between them because it's a positive 1. Now, we haven't talked about this yet, but I want you to know that we always need to write the variable term first and the constant term last. That's just standard form of writing expressions. So we need to switch these two and end up with b plus 40. All right, so we looked and we got the same answer either way, so it's pretty much up to you, whatever you prefer. All right, so before next class, I want you to try 5, 6, 7, and 8, and we'll review them in class.